Focus 5, we're going to learn how to use structured text within our controls project. So to use structured text, we are first going to need to create an add-on instruction, but in this case we're going to select new add-on instruction before we imported the add-on instructions. In this case we want to select new, and we're going to give that instruction this name, p underscore motor underscore data. And the type of instruction, we're going to use structured text. Now structured text is going to follow the format that is typical for a lot of different programming languages like C# or HTML or even JavaScript. So go ahead and select OK. Our new add-on instruction is created. So we have the following add-on instruction name. I'm just going to hit OK to create that add-on instruction. Now over here we can see our parameters and local tags and logic. Before we can start writing our logic, we need to define the parameters and local tags. So going back to the PDF of the curriculum, we need to create these tags in order for our code p underscore that's within p underscore motor data to be executed. So our motor data add-on instruction is going to call upon these tags, and we're going to basically do math with those tags to create our outputs. So I'm just going to, in this case, I'm just going to copy these tags. Current in, current out, efficiency out, horsepower out, power in output, power out output. That may seem confusing right now, but that's because we are using two different power values to calculate the efficiencies within the motor. We won't get into the code for that just quite yet. We have a couple versions of torque. We can have it in foot-pounds or in Newton meters. And then voltage in and out of the variable frequency drive. We want those tags to be either dint or real. I'm just going to make them real for all these, and I'm just typing RE and it'll automatically change it to real. So now we have all of our tags, and those are our local tags. And we need to set what these values are. So we're going to set the input and output as shown here. Efficiencies and output, horsepower was an output, power in was an input, RPM's an input, RPM out's an output. And this is important for the function block diagram that's going to go along with the structured text. So all of our tags are created for our P underscore motor data. Now, like I was saying, this is useful because even though we're writing the programming for this part in text, we can also go to our main subroutine, and now we will see an add-on that's called P underscore motor. If we add that to our page, we can look at the properties of our P underscore motor data, but now we have the ability to turn on these inputs and outputs that we just created. So now we can see those inputs and outputs of our function block diagram that is tied to our structured text logic that we're going to set up next. So I'm going to double click on logic. We were in parameters before and tags. Now I'm going to double click on logic, and we are going to write the actual code for P underscore motor data. Now that we have our tags set up, we can start to write our code. I'm going to start, and I'm just going to copy and paste this code directly from the Controls Lab curriculum. You can write this out by hand or change some of the names or parameters slightly if you wish, just to see how it's written out. When we write something in parentheses with this star notation, it's telling the structured text code, ignore everything that's in here. I'm just using it for a reference. So that's like a title you can give things to remember what your code is actually doing for that specific section. So I'm going to call this the RPM out and frequency outputs. The code that's going to go along with that is this. So I'm going to put that on the second line, paste that code. And it says if the RPM in is greater than 0, then I want the RPM output to be defined to be equal to the RPM input. And we can also define the frequency out as being equal to the RPM out divided by 30. Now I can see right now that there's something wrong with the code because this line is showing frequency out, and I don't think we added frequency out to the actual tags. So we're going to go ahead and change that. We're going to put a new tag in, and we're going to call it frequency out. We want that to be output. Real is fine. Now we can go back to our logic, and there, frequency out has now turned red, so it recognizes that as a valid tag, and it can do the math with that. RPM out is now red. So we can verify the routine. Basically, it says everything is good except we don't have an end if. So if this is the only code we wanted to have in there, we could go ahead and put end if. And I missed the underscore. I guess there's an underscore in that. And if we put that in, notice I'll get the error window up here. I'm going to dock that. Notice we have 0 errors and 0 warnings. So we can go ahead and continue putting in the code for the rest of that frequency output. Next, we're going to have the else and the end if for the frequency RPM output. So basically, if this condition is not met, the else means it will output this for a value. This will be beneficial in our HMI control panel for the user, because when the drive is not running, we want it to show the output as being 0. So I'm going to go ahead and copy that code, put that in. Use tabs to clean up the code a little bit. So we have the if, the else, and the end if. Notice it recognized our frequency out again. And now all the code for the RPM output is set. So the final code will look like this. Next, we need to do the same thing for our voltage code. I'm just going to copy and paste this code, and I'll talk through what it's actually doing. Now, the voltage coming off the drive is going to be enabled in Chapter 6. So I'm not going to go into why we're doing what we're doing here until Chapter 6, but basically we need to take the voltage that the drive is giving us and divide it by 10 because of the scale factor that the drive has sent the data to us. And then the current we got to divide by 100, again because of the way they scaled the drive data being output. So basically we need to divide by 10 and 100 there. And if that condition is not met where the voltage is bigger than 0, then we again want to output zeros for the data, and then end if. Next is our torque and power outputs. I'm just going to copy and paste this code in to the system, but basically I have the equations or the mathematics behind the actual inputs. I'll just tab those over to clean those up a little bit. But basically, structured text allows me to do math. Here's my scale factor to compute the torque in terms of power and RPM. So we can use power and RPM to get the torque, and that's my scale factor for this specific size drive. So we can take that number, multiply by the power input, and then we have to multiply by 10 and then divide by the RPM input that we see from up here. So structured text allows us to do math kind of like a basic graphing calculator or calculator would do. We can divide, multiply, add, subtract, do whatever in terms of text, and it will simplify our programming process versus using add-ons for add, subtract, multiply, divide, because we would need an add-on for each one of those if we were to use the full function block for this. So now we have the code for the torque, and then I believe the last one is horsepower. I'm just going to go ahead and copy that. That's an equation. That's just a basic equation for converting torque to horsepower. Once we have the torque, we can convert to horsepower down here. Notice that since this code is going to execute in a straight line all the way down from left to right, we have our any variables that we call upon from previous code that's already been executed can be added to code below in order to finish more code. So that's a trick to use when you're programming this type of stuff, is you can call upon something from up here because it's already been executed through the process logic controller. So once we have all of that information into that that add-on module that we created up here, we can go ahead and go back to the main routine. So now we're done with that code. We can verify that code if we want, but it shows as being okay. Now we're going to go back to that main routine where we added this motor data module. So basically we can wire inputs and outputs to this so that our function block that goes along with our structured text will properly execute what we need it to do. But as I said before, we're not going to cover drives until variable frequency drives until chapter 6. So our input parameters that we need to set up here are not available at the current moment. But we can set up all of our outputs. So I'm just going to add a bunch of output references, and we're going to add those tags to the project so that we have it. Need 2 more. And then wire all of our outputs. And then we can name them. So we have output underscore current, output underscore efficiency, output underscore horsepower, output underscore power out, output underscore RPM, output underscore torque, and I'll just put FTLB, output underscore torque in Newton meters, and output underscore voltage. Now we'll see that we still have errors in this, but that's because we didn't create the tags. So we just need to create a new tag that's a real, and the scope is my controls project. We'll create new tags for all of these, and those tags will be defined in the controller, and then we can call on these tags when we set up our actual HMI interface. So we'll call upon those tags when we're setting up the controls for the actual factory talk HMI interface. So we can set that up later on. So now that we have that set up, our new motor data add-on instruction is ready for calculating those values for us based on inputs that it gets from the drive, which we will set up in chapter 6. So that is it for using an add-on instruction to do function block programming within